Hi everyone. Today's lesson is going to be on converting factored form to standard form. So you know that we recently introduced factored form, which is this one up here. And factored form shows us the zeros. So when we have a quadratic in factored form, we can read off the zeros really easily if we remember the rule of zeros. Standard form is this one here. That's where we started talking about quadratics. Standard form is a little bit difficult to extract the information from, except for the y-intercept, which is this number here, the c value. So another name for standard form is y-intercept form, because you can read the y-intercept really easily. So because we sometimes are presented with an equation in factored form, and sometimes we're presented in it with the same equation in standard form, one thing that we need to be able to know how to do is convert from factored form to standard form, and from standard form to factored form. Okay, and the way we do this is we use two procedures, only one of which I'm going to do today. And from factored form to standard form, so for this one right here, we call that expanding. Expanding, okay? So today we're going to be spending our time expanding. One of the tools that we use to represent expanding quadratics are algebra tiles. Here are some algebra tiles that I just mocked up in my little sketchpad here, and each of these tiles represents a different value. The large ones represent x squared, and red represents positive. So this one here is positive x squared. Blue represents negative. So this one with the same shape but blue in color would be negative x squared. These two guys, these two red ones here, both represent the same thing, though those ones represent positive x. You'll see in a second why they have two different shapes. The ones next to them are negative x. And these two little ones on the end represent positive 1 and negative 1. So these are the only tiles that we'll need. We may need more of them, but these are the only tiles that we'll need to do all of the expanding in this unit. Okay, so here's a very typical question. We're asked to expand x plus 1 and x minus 2. And really whenever we say the word expand, what we're really doing is we're multiplying. So think in your mind, whenever you see expand, really we mean multiply. To set up my expansion, I'm going to create a chart. It looks something like this. So here's my chart. And I'm going to take tiles from my collection here and fill them into the chart. So what I normally do is whatever the first factor is, x plus 1, I'm going to select tiles and put that down the column. And the second term here, I'll select tiles and put those across the top. So just give me a second while I do that. Okay, so now I've selected tiles. I had to make a few copies in that case, but really all I've done is use tiles to represent this as x plus 1, right? The long one here that's red is positive x, and the little guy is positive 1. Along the top I have positive x, a positive x tile, and two negative 1 tiles, so that's going to be negative 2 altogether. Within the chart, I'm then going to just to sort of draw your eye here, I'm going to draw in these lines, like here and here. Okay, so now in the first box, this one here, I am going to multiply x with x, and that's going to be x squared. So I'm going to take my x squared tile and put it in right there. In the next in the next spot in my chart down here, I'm going to multiply 1 times x. So for that, I need another x tile, which I will get in just a second. Okay, got it. Now I'm going to do the same thing in my third spot in my chart. I'm going to need some negative x tiles. So I'm going to grab this one here and bring it down. There it goes. And I'm going to grab this one here and bring it down. There it goes. And I'm going to grab a couple of these guys down here and down here. Okay, so now what I've done is I've represented this multiplication using algebra tiles. And what I want you to see, like why this sort of works, or why this, kind of makes sense once you get used to it, is that the size of the tiles on either side indicates the size of the tiles produced by multiplication. So in here I have a long side and a long side, and I get a tile which is long on both those sides. So that's kind of why, in one way, if I have x here and x here, I get, when I multiply them, x squared. Also, if you see, I have a long side here and a short side here. So that's why I produce a shape that has a long side here and a short side here. But since this is -1, -1 multiplied by x gives me negative x. And this one is also -1, so this gives me another negative x. Down here, I have a short side here and a long side here. This is 1. 1 times x gives me positive x. And for the little guys in the corner, again, they have the two short sides, short side, short side. That produces a little square with a value of -1. And over here, -1. Now the last step is looking for things that cancel each other out, or that add to 0 more properly. So when I have a negative x tile, that adds to 0. That produces 0 if I add it with a positive x tile. So this tile and this tile are going to add to 0, because really everything in the chart here, everything in this part of the chart should add together. So this tile and this tile will add to 0. All the other tiles that are left over, I then add up, and I would get, in this case, an x squared tile. Well, I can't quite grab that. Anyway, I'll just write it down. I will get an x squared tile. I'll get one negative x tile rather, left over, and I have two -1 tiles. So this -2 here comes from these little guys. This negative x comes from the one negative x tile that was left. These two tiles add to 0, so they're gone. And this x squared is this one here. Now, we normally show you with how this looks with the tiles first up, but we pretty quickly want to move to a situation where we get rid of the tiles, where we abandon the tiles, and here's how that kind of looks. I set it up exactly the same way. This is x plus 1. This is x minus 2. I usually draw my lines exactly the same way, at least for the first few times I'm doing this. And so here, in the first square, I'm going to have x times x, which is x squared. Below that, I'm going to have x multiplied by 1, which is x, just x. Then, in this tile, or this square, this space, I'm going to have -2 times x, which is 2x. Finally, in this space, I'm going to have negative 2 times positive 1, which gives me negative 2. Okay, so now the last part where I have to add everything together. This is a little bit tricky because I can't just look for tiles which cancel each other out, as was the case here. I have to write down all of the terms and then simplify. So here I'm going to have x squared plus x minus 2x minus 2. All right. Now, if I keep on simplifying, my x squared term and my negative 2 term there's only one x squared term, so that one's done. There are no other constant terms, right? Terms that don't have x's at all. So this is the only term like that, so that one's done. What I have to do though is I have to simplify this. I have to take an x and subtract off 2 more x's. So what I have in this case is I have x squared. 1x minus 2x is going to be minus x, or negative x, minus 2. So that's my final answer. So you can see that I do in fact get the same thing as I had over here. Same thing. But I arrive at it in a way that doesn't involve algebra tiles. Okay, I'm going to do this. I'm going to do a few more examples, and if you'll forgive me, I'm going to do this next one without the algebra tiles, just because I want to keep things a little bit shorter on time. So I'm going to expand. I'm going to expand x minus 2 and x minus 3. Again, I'm going to set up my chart like this. X multiplied by x is x squared. X multiplied by negative 3 is negative 3x. Negative 2 multiplied by x is negative 2x. And negative 2 multiplied by negative 3 is positive 6. Now I'm going to simplify, and I want to point something out. The x squared term, there's only one x squared term. There's only one constant term, but the x terms, the linear terms, are along the diagonal. So if you know to look along the diagonal, this is where you can add up the x terms a little bit easier. So if I simplify, this is going to be x squared minus 5x plus 6. Okay, let's do another example. I'm going to, in this case, expand these two terms. So you can see that things are getting a little bit more interesting. I have 2x plus 1, 2x minus 1. Set up my chart like this. Now, in the first square, you have to be very careful here, because sure, if I multiply x by x, I will get an x squared. That's easy enough. But what about the 2 out front? Well, remember that numbers multiply numbers, variables multiply variables. So in this case, 2 multiplies by 2, and I have 4. So 4x squared altogether. In the second spot here, 1 times 2x is 2x. In the third spot here, 2x times negative 1 is negative 2x. And in the final spot here, I have 1 times negative 1 is negative 1. Now this is the cool part. Again, if I look along the diagonal, I see I have 2x minus 2x, so the diagonal will just be 0. And simplified, this is 4x squared minus 1. Okay, so this is my last example, And in this case, I have not only am I expanding these two terms here, but I also have a number out front. And if you remember from our discussion of quadratics, this number out front is like our a value. So we aren't always going to have an a value of 1, which is what I had in the previous examples to keep them simple. So we got to know how to deal with an a value that is not 1 and how to expand it properly. So what I'm going to do is I'm going to focus my attention first on multiplying or expanding these terms, and I'll worry about the 2 last. So I'm going to write the 2 just so that I don't completely forget it, but then I will put my chart like so: 3x minus 11, 5x plus 1, whoopsie, put that in there. Okay, close my bracket. And so then I have 3x times 5x is 15x squared, right? Don't forget, x multiplies by x to give me x squared. Below that, I have negative 55x. Then here I have 3x times 1 is 3x. And finally, below that, I have negative 11. Okay, so again, we see the linear terms are along the diagonal. So this becomes 2 times 15x squared minus 52x minus 11. Again, that 52 came from adding along the diagonal. 3x minus 55x is negative 52x. Okay. So finally, I have to distribute this 2 out front into each of these 3 terms. So once I do that distribution, I'm going to have 2 times 15 is 30x squared. 2 times negative 52 is minus 104x minus 22. Okay, that's my final step. That's fully expanded. Okay, so that's it. I did 4 examples. Lots of examples today to deal with all the different situations. If you didn't catch it the first time, go back and look at the videos. Go back and look at the video again to make sure you've got it. Copy down the examples, and we'll talk more about them in class. See you then.